Okay, you guys, I want to go over these 4 examples from Professor Dave's video on molecular geometries. We'll start with phosphorus pentachloride. You see? Okay. Phosphorus has 5 electrons in its valence shell, and chlorine has 7. So when those come together in a dot structure, chlorine is each of the 5 chlorines is gonna grab on to one of those electrons that phosphorus has in its valence. Okay? 3, 4, 5, and share its 7th unpaired electron. And phosphorus is a little bit bigger, so it can have 10 electrons on its shell, especially when it's sharing all of those. It doesn't always have them. And then you have your other 3 electron pairs on each chlorine. Okay. Your line drawing on that is a trigonal bipyramidal. So think about 2 pyramids stacked on top of each other. And if we look at the electronegativities, phosphorus is 2.1, chlorine is 3 for a difference of 0.9, which is polar covalent. The chlorines will hold on to those electrons just a little bit more than the phosphorus, which will create polarity towards the chlorines, but because each of those chlorines will hold similarly, or they're each chlorine, so they'll have the same pull on those electrons, and it's a symmetrical structure, it does not have an overall dipole moment. They're all pulling the same amount in opposite directions. Here's my model structure of that. Okay, I have the top, the bottom, and the 3 around the side. Let's do sulfur dioxide. Sulfur and oxygen both have 6 electrons in their valence shells. And when they come together, you're actually going to end up with double bonds. And because of this lone electron pair here, you have 3 domains on your central atom, which is gonna, you're gonna have that big electron pair up here, which is gonna push down your other bonds. So you have a bent. Here's your bent. I forgot to give you your angles here. You actually have 2 different angles here in your trigonal bipyramidal. This angle here, this one, is 90 degrees. Can you see that? How that's 90 degrees? And then this one here, where you have 3 around the central, that's 120 degrees. Okay, 120, 90. This one, they're all 120. Okay, it's just a triangle. Take your 360 divided by 3. And your electronegativities on sulfur dioxide are, let's see, oxygen is 3.5 and sulfur is 2.5 for an overall value of 1, which is also polar covalent. So you're going to have those oxygens pulling a little bit more, which is going to create an overall dipole moment on your molecule because they are both pulling away from the center. Next one is ammonia, NH3. Ammonia has, or excuse me, nitrogen has 5 electrons in its valence. Hydrogen has 1. So your dot drawing will be 1, 2, 3, 4, 5. Your hydrogens will come on there. And now you have 4 domains around your center atom. Oh, sorry about this. 4 domains around your center atom, the 3 hydrogen bonds plus that lone pair. So you're going to have a tetrahedron. Oh, and this is your lone pair. There's not actually a bond. It's just your lone pair, which looks like this in your models. Okay. That lone pair is taking up lots of space and pushing these all down a little bit. Okay. And if you look in your book, this angle is 109.5. Electronegativities, nitrogen and hydrogen. Let me take a peek. Nitrogen is 3, hydrogen is 2.1 for an overall of 0.9, which is again polar covalent. They're all going to pull towards the center, towards that nitrogen. Because they're pulling towards the center, there will be no overall dipole moment on that atom. Excuse me, on the molecule, not the atom. And the last one, beryllium dihydride, I guess it is. BeH2. Beryllium has 2 in its valence and hydrogen has 1. So it's just going to share one of those with each of those hydrogens. There's no lone pair left over. It is linear. It's 180 degrees. Electronegativities. Beryllium, hydrogen is 2.1. Beryllium is 1.5 for an overall difference of 0.6, which is also polar covalent. But it's pulling towards the beryllium and again towards the center for no overall dipole moment on the molecule. I hope this was helpful. You guys please reach out to me. I know this was a hard one and I want to give you what you need for your understanding. Okay, good luck.